Okay, continuing with 3.1, we were just talking about pairs of lines, like parallel lines or skew lines. So if I have two lines in a plane, I'm going to call this line L, a second line that's not necessarily parallel, although it could be with the first line, and then a third line, I'm going to call that line T. That line T intersects at least two lines, L and M in this case. So that third line there, T, is a transversal. Transversal is just a line that intersects two or more lines. So it's actually the case that L is also a transversal because it intersects line T. And since L and M are not parallel, L could be the transversal. And then the same with line M, line that intersects two or more other lines. But right now, let's just talk about T being the transversal. So if T is the transversal, then we could think about T, L, and M forming the following angles. I'm just going to number them. So here's angle 1, angle 2, angle 3, angle 4, angle 5, 6, 7, and 8. And then in that diagram as well, okay, angles 3, 4, 5, and 6 are between the two non-transversal lines. So all of what I just shaded in is the interior because it's between lines L and M, the non-transversals. Okay? So for those, there's some interior angles in that diagram. Interior angles in that diagram are angles 3, angle 4, angle 5, and angle 6, which means angles 1, 2, 7, and 8. Here's angle 1, angle 2, angle 7, and angle 8. Those are the exterior angles. They're outside of those two non-transversal lines. So individually, angles 3, 4, 5, and 6 are interior angles, and then individually, angles 1, 2, 7, and 8 are exterior angles. They're outside of the two lines. But then let's talk about in a minute, once I clean up the diagram, angle pairs. Okay, so now taking a look at specific pairs of angles in the diagram. There's pairs of angles that we've already talked about and defined before, like there's linear pairs of angles, there's vertical angles. So you should know those. These are just the new pairs of angles. One new pair of angles are corresponding angles. So corresponding angles are a pair of angles that are in corresponding position. And by corresponding positions, a pair of angles in corresponding positions. So we're talking about pairs of angles. That means two. You can't just have an angle that's a corresponding angle. It has to be a corresponding angle with another angle. But if I look at just one angle, such as angle 1, here's what I notice, and here's what you should notice as well. Sorry, I didn't label this line. This is line T. That's the transversal. Notice angle 1 is above line L, and it's to the left of the transversal. So an angle that corresponds with that, angle 1, and another angle that's above its line is angle 5. Angle 6 is also above the line, but it's to the right of the transversal. So angle 5 is to the left of the transversal and then above its respective line. So angles 1 and angle 5 are corresponding angles. Those aren't the only corresponding angles in the diagram. There's no other angle that's corresponding with angle 1, but again, maybe pause and then think about what another pair of corresponding angles are. So another pair of corresponding angles, if you thought about it, should be angle 2. It's to the right of the transversal and it's above the line L. So angle 2 and angle 6 are corresponding angles. There's more corresponding angles in the diagram. Angles 3 and angle 7 are corresponding angles. And then lastly, angles 4 and angle 8 are corresponding angles. Those are pairs of angles. Okay. Another pair of angles in the diagram. We talked about the interior angles 3, 4, 5, and 6. Now we'll define a pair of angles, alternate interior angles. They have to be interior angles. So you can't have angles 1, 2, 7, or 8 be alternate interior angles, but interior angles that are non-adjacent. So a pair of interior angles that actually are adjacent are 3 and 4. They can't be alternate interior because they have to be non-adjacent. On opposite sides of the transversal. So in this case, there is an alternate interior angle with angle 3. Can you figure out which angle it is? It has to be angle 6. Can't be angle 4 because those are adjacent angles. By the definition of alternate interior angles, they have to be non-adjacent. It can't be angle 5 either because those are on the same side of the transversal. Can't be 1, 2, 7, or 8 because all of those are exterior angles. And there's one more pair of alternate interior angles in the diagram. The other pair of alternate interior angles in the diagram are angles 4 and angle 5. Those are on opposite sides of the transversal. They're interior angles, and then they're non-adjacent angles as well. So similar to alternate interior angles, in that diagram, there are pairs of alternate exterior angles. I could take almost the exact same definition for alternate interior angles, except change interior angles to exterior angles. Exterior angles that are non-adjacent on opposite sides of the transversal. Or I can define it like this, okay? Just non-adjacent exterior angles, just changing the wording around slightly. On opposite sides of the transversal. While I was writing that down, did you think about what a pair of alternate exterior angles could be? So you could rule out, I would say fairly easily, angles 3, 4, 5, and 6 as being alternate exterior angles. The reason why you could rule those out is 3, 4, 5, and 6 are the interior angles. Remember, between lines L and M, so this shaded in region here, that's the interior. So 3, 4, 5, and 6 can't be alternate exterior angles. If I just take a look at one of the exterior angles, angle 1, you know what angle could be an alternate exterior angle with that? Can't be angle 2, even though angle 2 is an exterior angle. It's adjacent to angle 1. Can't be angle 7 because those are on the same side of the transversal. They're on the left side of the transversal. So angle 1 and angle 8 are alternate exterior angles. And then there's one more pair of alternate exterior angles. That would be angles 2 and angle 7 are alternate exterior angles. They're exterior angles that are non-adjacent, and then they're on the opposite sides of the transversal.